Hi, this is Trash Dev. I'm Tapioca. This is episode 2 of my series about developing Lakeside, a fishing adventure RPG. In the last episode, I got you up to speed with where the game is today, and promised that in the next video I would work on implementing the fishing. In this video, I'm going to tackle the most boring part of the whole process, the main data structure and tool development. When you boot up Lakeside today, you can get as far as equipping a fishing rod and casting your line, but after that, nothing happens. That's because there's no way for the game to know which fish the player should actually be able to catch. So the problem we're faced with is that we need a way to define what fish are catchable for every water tile in the game. The way I'm going to accomplish this is by making tables of fish and then assigning a table to each tile. The fish types and tables will all live in one large JSON file, which I'll need to create a program to edit. Up until this point, I've kept all my development tools in the same executable as the game itself, which I think has a lot of practical benefits. The drawback is that I had to create the entire UI system myself, and while it does work pretty well, nothing I make is ever going to be as good as the native Windows components. I'm going to have to use this program to make potentially hundreds of fish and tables, so the UI needs to be as frictionless as possible. And since JSON is so easy to work with, it's not a big deal to have two different programs reading and writing it, which was the main reason for combining the game in the editor in the first place. Anyway, let's start working on this. The first step is defining the structure of the JSON file, which I just did quickly in Notepad. From here, I drew this crappy MS Paint sketch of how a program that creates this JSON structure could look. There's a tab for creating fish, a tab for adding fish to tables, and a tab for file overview and operations. I won't go over what every field is or what it's for, but basically, every fish needs a name, description, sprite, size range, and some Lua functions for the gameplay. Some of these things will always be the same for that type of fish, so they live in tab 1, while others can be varied by where they are in the game, so they'll live in tab 2. I decided to make this program in Python using the Qt bindings, since I've done it before for other projects. Python is always fast to write, but it's probably best suited for quick throwaway scripts and not real projects. This is a mistake I've made many times in my life. I'm going to make it again today, and I'll probably keep making it in the future. And after hours of miserable programming, it's done. I really regret using Qt for this. I kinda hate it now, if I didn't already hate it before. I will definitely never make this mistake again, I think. So you can see here I've created a number of fish. I've already entered in all kinds of things. Whenever I make a new tool like this, I like to do a sort of real-world test of it where I do a bunch of creating of things, and then hopefully from that I'm able to tell sort of what the friction is, what assumptions I had when I was making the program that are wrong, sort of what features are missing that I didn't even know I would need until I actually discovered I needed them. And sure enough, I did discover a few things that are missing from the program. This is just the fish tab, by the way. The tables are over here. You can see we've got a couple tables. We can move the fish back and forth, remove the bass from the table, re-add the bass to the table, type in whatever we want for any of this stuff. Actually, that should probably be a number, shouldn't it? But I did notice two problems with the program, actually, and problem number one is right here on this tab. It's the fact that I can't name these tables. Right now it looks kind of fine because I only have 3 tables, but they're all just called table, and I can't really tell them apart from their ID numbers. So once we have like 100 of these, it's going to be basically impossible to tell them apart, and it's going to become an unmaintainable nightmare. So definitely need to have some kind of way to name the tables just so I can tell them apart. The other problem I was having with the program is actually in this file tab with these lists. And the point of these lists is to show me every Lua function that I've created across all of the fish and all of the tables. So like if we look over here, every fish has a catch function associated with it. And if we look in the tables, every fish in here has a frequency function associated with it. And all of that is meant to be listed here so that I can sort of see at a glance what every function I've written for myself is, and then when I'm going back later to actually write all of these Lua functions, I can refer to the list and I can make sure that I haven't missed any. So it's really important that there's nothing redundant or useless in these lists, which is why when we have a %0.4 and a %0.2 and they're both displaying even though they're the same function on this list on the right, that is not acceptable. We need to make sure that it can tell that that's the same function and only list it once. I think it would be neat to also have highlighting implemented here so it actually looks at the Lua file with the functions and then highlights the ones I haven't written yet. I think that would be helpful. So now we have a way to create fish and organize them into tables. The next step is to load the JSON file into the engine and update the map editor so I can assign those tables to map tiles. This was actually really easy, and the only tricky part was creating this new UI element that displays the contents of a table. I also went ahead and created a new map overlay that shows which tiles have tables assigned to them. Map overlays are a sanity check feature similar to what I was doing with the function lists in the table editing program. The point being that I can quickly see at a glance otherwise invisible properties of tiles, like the collision or water depth, to make sure I haven't made any mistakes anywhere. For the table overlay, I used a hash function based on the table ID to give each table a unique highlight color, though you can't really tell that because the 3 tables I made all happen to have a similar shade of blue. And with that, I'm going to call it here for this video. After spending hours on boring tool development and some map editor features, the end result is that when selecting a tile to fish on, the game now knows which fish are possible to catch. In the next video, I promise we'll actually get to talking about the fishing mechanics itself, and hopefully I'll have made good progress on implementing them. Until then, thanks for watching, and I hope to see you next time.